Welcome again to another math session at Panther Math Corner. This is Dr. Howard. I am a math teacher at Pasquotank County High School. And we're continuing our series with the inequalities, solving inequalities using the properties of inequalities. The last video I demonstrated using the addition property of inequality. In this video, I will present the subtraction property of inequality. I will do several examples and also graph the solutions with explanation. You can see here I have a similar set of inequality property rules. Just take a quick glance, but recognize that in each expression you see the value negative c and on the left side and right side of the inequalities, and I explained from the last video that it represents part of the equation when you're canceling out, and I'll demonstrate right now and show you what the c value represents. Now, given this example, y plus 8 less than equal to 5. Okay. All right, so we recognize that this is your A and this is your B. Okay. When we use the properties of inequalities, in this case, the subtraction property, it will create the C value because it's used to cancel out. Whenever you're using addition or subtraction, the C value comes. All right, so if we, since we have a plus, we're going to use the subtraction property to produce the cancellation. And this is your C value. Okay? All right, just try to see if you can figure this out now. So this is your A. It's part of the equation. Your B right here is your B value, which is a constant number after the inequality sign. And your C value begins when you start using the properties. Whether it's addition, you add. In this case, you're subtracting because you got a opposite sign that you're trying to cancel out your properties, your quantities. And positive and a negative will cancel. So this cancels. So your y comes down here, and then you have less than equal to negative 8 on both sides. What you do on one side, you do on the other. You have a negative 3. All right. Okay, your solution set here is y is less than equal to negative 3. Now let's graph. All right. Have negative 3. I'm going to put positive 3 here. All right. Okay, let's do the test. It says y is less than negative 3. It means any number less than negative 3. Let's put some values. I'll put a 0 here. Let's do this. 0 is less than equal to negative 3. True or false? All right. Is that true or false? 0 is less than negative 3. That's false. All right. Let's do another one. 1 is less than negative 3. True or false? This is false again. All right. But if we try another value, 3 itself, negative 3 less than negative 3. True or false? That's true. Let's try another one. Let's try negative since it's going in that direction. Negative 4 less than negative 3. True or false? So that's true. So that means that this inequality will include values less than equal to negative 3. This is less than equal to negative 3. That means that you're going to have a closed circle. All right. You're going to have a closed circle. All the values that are less than negative 3 are going to the left. All right. So that's what your graph look like. All right. All right. That describes the graphing the solution, inequality solution. Okay. All right. Let's try another one. I'm going to erase this. All right, let's try this one. Negative 8 less than 1.4 tenths plus m. All right, it's got a decimal, but it's all right. It works the same way when you solve it. So you have negative 8 less than equal to, oh, not less than equal to, it's less than. I'm sorry. All right. Yeah, this is the correct one. Okay, right. Okay, negative 8 less than 1.4 tenths plus m. So we have m as a variable. Like all equations, when you're solving, you want to get this variable by itself. Since m is on the right side, it doesn't matter. All right, as long as the value is away from m, some value. So let's use the subtraction method. This is a positive 1.4. If you don't see a plus sign next to it, but you see this operation sign, you have to assume this is positive. So we're going to use the straight line method. We're going to subtract 1.4 on both sides of the inequality sign. All right. This cancels. You have less than m. And if you add negative 8 plus 1.4, you should get negative 9.4. Right? So negative 9.4 is less than m. Okay? Negative 9.4 is less than m. So let's draw the graph. Let's graph the solution. All right, let's do 9.4, 9.5, 9.4, 9.5. All right, here we go. All right, what kind of circle will this be? Will this be a closed or open? Since there's no less than equal sign or greater less than equal sign here, it's going to be open. All right, so it's going to be open over negative 9.4. Excuse me. So here's the question: which direction that will include the solutions that represent m 9.4, negative 9.4 being less than m? All right, so we have to test it. Let's do the true and false again. 9.4 is less than negative 9.5. True or false? All right. Is negative 9.4 less than 9.5? No, it's not. It's false. You remember when I was telling you that the numbers in the negative, as your higher numbers are going to the left, they become lesser in value. So negative 9.5 is not greater than negative 9.4. Actually, negative 9.4 is greater than negative 9.5. In this case, this is a false statement. So it can't go this way. So let's try the other one. Let's try the other side. Let's say negative 9.4 is less than 0. True or false? Yes, that's true, because any negative number is less than 0. 0 is greater than all the negative numbers, so that should be an easy one. Matter of fact, anytime you see that, you can always use 0 when you're comparing negative numbers involving the inequality sign, because 0 is greater than all negative numbers. So in this case, excuse me, this will go into this direction. All right, so it's a, let me change that. All right, it's a open circle going this way. All right. So this is a true statement with it. That is negative 9.4 is less than 0. So your solution set for the graph will go in the direction to the right. Okay. I hope you can see it. You can pause it and you can take your time. I'm going to do the last problem. All right. So it's a fraction. It's a fraction. 5/6 is less than equal to z plus 1/6. All right. With this problem, got to get z by itself. I'm going to put a little dash. I like to put a little dash in my z's. Got to get z by itself, so this number has to go. So since this is plus, using subtraction property, we're going to subtract on both sides 1/6 using straight line method 2. All right. A plus and a minus of the same quantity, they always cancel. All right. Less than equal to z. All right. 5/6 minus 1/6, that's easy because you have the same common denominators, just subtract the numerators. So it'll be 4/6. And also 4/6 can be reduced to 2/3 less than equal to z. Okay. All right. Now, this should be easy as far as graphing. 2/3 is less than equal to z. So think about numbers that are less than 2/3. All right, so we'll draw the graph. And I'll put a negative 2/3 and a positive 2/3. All right. All right, let's do the true and false again. 2/3, and pick any number on the number line to represent z. 2/3 less than equal to 0. All right. True or false? Is 2/3 less than 0? No. No, 2/3 is not less than 0. That means that all the numbers less than 0 are going to the left. So that's false. So if I say, let me repurpose this. I'm going to repurpose this. All right. I'm going to erase this here and put another value and see if it works. True or false? Is 2/3 less than equal to 1? Is that true or false? That's true. So that means that 2/3 less than equal to 1 is going to the right. All right, all the numbers that are less than 2/3 are going to the right. So they are all positive. So I'm going to look at this sign. This is less than equal. So it means that it's a shaded. Now I like to put the shaded above the graph. Now some students may want to do it like this. It's all fine. But you know, if you use another colored pencil or something to see the line and direction, it's fine. All right. But I like to put it above the line. That's just me. Right, it still illustrates the same thing, and you understand the concept. All right, so 2/3 interval set will go to the right. All the numbers that are less than 2/3, they're going to the right. Okay, because if it goes to the left, that means that 2/3 is less than -1. 2/3 is less than -2, which is all false. One of the good ideals is to try 0 all the time. 0 will be the best non-number to test, because anything less than equal to 0, you can easily see it. I just allow myself to include other values that you can test. Okay, this ends the session for subtraction property. My name is Dr. Howard, and thank you for joining me at the Panther Math Corner for another session, and I will develop more videos to cover multiplication and division properties of inequalities. You have a great day. Thank you.